Hello everyone. Today we are going to discuss lead code problem 98 valid binary search tree. So as we can see that here given a root of a binary tree determine whether a tree is valid binary tree or not. And we have a here we have given us some definition of what is a valid binary search tree. So in a left subtree node contain only the node key less than the node key, okay, and the right side is all the grid tree. So BSC is generally sorted structure, so we can, if we do in order traversal of the tree, then it would be the sorted output. So we can see that here we have a 1 2 and 3 which is sorted, and if we traverse 1 5 and 3, or here 3 is not a sorted. So this is not a binary search tree, and we cannot directly recur like if we start from the root, and if we check like left child is smaller than the root and the right child is greater than the root, and then if we check recursively this kind of problem, then it will give a wrong answer for this kind of a tree. So so how we are going to think whether BST is valid or not. So let's take one example like 5 and left subtree is 4 and 8 and 7 and 9. So here if we check in subtrees, for this subtree, let me change color. For this subtree and for this subtree, so this entire subtrees we defined a bound. So let's say for entire this and this entire tree, value can be minus infinity and plus infinity between these two value, okay. And for this left subtree, we have a lower bound is minus infinity and upper bound is this root value minus 1, that is 4. So in this left subtree the value should be between these two, okay. And for this right subtree, so we have a lower bound is equal to this value plus 1 which is greater than 6, so entire node should be greater than 6, and upper bound is plus infinity, okay. So if we go further, suppose if we take this subtree, let me change color, let me delete this value. So let me, uh, for this subtree we can like for 8 we have a lower bound is 6 and upper bound is plus infinity, okay. And for 7 we can define minimum value should be this value minus 1, that is, sorry, minimum value would be 6 and maximum value would be this minus 1, that is 7. So value should be between 6 to 7, okay. Similarly for 9 we can define lower bound and upper bound. So upper is infinity, but lower is this value plus 1, that is 9. So here we have value between 9 and infinity. So this will return true, this will return true, and entire return true, and here we are return true. So at the end we will, our root will return true. So similarly we use recursion, Let's write a code, I guess. And here some problem with integer value, so we need to check our value is not overbounding. So let me define minimum would be min, and the maximum value would be okay. Now we are going to recurring. We will take a tree node and we are going to take long. Let's take long so it won't get overflow. Minimum value and maximum value. Okay, and if root is null, then we can directly say that it's a BH tree. This is a trivial case and a base condition for our recursion. And we are going to check that if our root value is lesser than our minimum value or root value is greater than our max value. Okay, in these both case we are going to return false. Otherwise we are going to return, we are recurring both left subtree, that is root left, and as I shown in this diagram, that uh, for this tree we have a minimum, and upper bound would be uh, this root -1, that is root value -1, and our root value is integer, so for get rid of overflow we will typecast it. And similarly we have to recur in a right side. Okay, we are going to pass value, but for this case our minimum value is root value +1, as I shown here. Our for this left subtree the minimum value should be greater than the root. Okay, and the maximum value would be maximum. Okay, so am I missing any? And we need to typecast our value to get rid of overflow. Let's return recurring root minimum and maximum value, and let's check for the output. Yes, let me run. Yeah, it's perfectly fine. So hope you understand the recursion how it's working. If you like, then please give a like. If you have more suggestion, then you can give in comment section. And for a future video, don't forget to subscribe. Thank you for watching.